Hi everyone, myself Harshaji. I am from Sri Venkateswara College of Engineering, Department of Mechanical Engineering. Today I am going to present a technical seminar on the role of 3D printing and additive manufacturing in medical applications under the guidance of Mr. Sridhar V. Deshpande, Assistant Professor, Department of Mechanical Engineering. So next, coming to the contents, there are introduction, type of 3D printers, working or implementation, 3D materials, 3D printing in healthcare, conclusions, and some references. So here comes a introduction. 3D printing technology evolved in the year 1980s but has made greater strides in the last decade from both a cost and accessibility standpoints. While most printers are employed for commercial use, medical 3D printing is a growing application which serves to aid physicians in the diagnosis, therapeutic planning, and potentially the treatment of patients with complex diseases. In this article, we will delineate the types of printers available to the consumer, the various material which can be utilized, and potential applications of 3D modules in the healthcare field. The 3D printing technology represent a big opportunity to help pharmaceutical and medical companies to create more specific drugs, enabling a rapid production of medical implant and changing the way that doctors and surgeons can plan procedures. So here is the type of 3D printers. Printers can be divided into two basic groups. 3D printers in that additive and redditive. Additive printers. In additive printers, additive machines deposit layer upon layer of materials, progressively building the model into a three-dimensional shape. In a redditive process, the printers begins with a block of materials which is progressively cut away to reveals the final shape. So in additive printers, it will deposit a machine layer upon layer. In reductive process, the materials will cut away the reveal to give a final shape. Additive printers are fused deposition modeling FDM printers. So FDM is nothing but fused deposition modeling. The stereolithography SLA style printer, digital light processing DLP printers, polyjet printers, selective laser centering SLS, selective laser melting. So this is a reductive printers. Reductive printers are also available including laminated object manufacturing LOM machines. So LOM is nothing but laminated objective manufacturing. With this technology, this layer of materials or paper, plastic and metal are glued together and the cut away with the thin blade or laser. Though this is will be cutted in blade or lasers. More layers can then be laid down and the process repeated to complete the model. So this is a reductive printing printers or LOM. So LOM is nothing but laminated objective manufacturing machines. So this is a machine reductive printers takes place. The working of 3D model. Different printing techniques and materials are available in order to better reproduce the patient anatomy. Most of the available printing materials are rigid and therefore not optimum for flexible and elastic unlike biological tissues. So here is a 3D printing workflow. This is a flowchart how the 3D printing works. Image acquisition, target area selection. After that, segmentation, DICOM to STL file conversion. File optimization for final print. 3D printers and material selection. After that, print, validation and quality control. This is a flowchart of 3D printing. In this analysis, an overview of 3D printing application in medical field is presented, highlighting the usefulness and limitations and how it could be useful for surgeons. FDM printers serve as a cost efficiency means of establish a medical 3D printing lab. There is a use of smaller size, low cost filament and commercial availability makers them ideal for physicians interested in entering the areas of 3D printing. Here is the printing process. Many printers allows the users to control the temperature of the nozzle, facilitating the use of various filaments with different melting points. Most FDM printers move the nozzle in XY plane, drawing a layer of molten materials onto the printer bed. After a layer is completed, the bed descends or the nozzle rises and the subsequent layer is deposited onto the prior. The printer bed is flat surface, often glass, which the model is built. Some printers allow users to heat the printer bed to improve the additions of certain filaments. Utilizing an addition agent improve the bond between the initial layer of the model and the bed. There are many addition agents available which are liquid and or glues that are painted onto the bed prior to print. So coming to the 3D materials, so these are the materials used for 3D printing: hard plastics, flexible nylon and thermoplastic polymers, and dissolvable supports, and ceramics, and last paper and metal alloys. So these are the materials used for 3D printing. So coming to 3D printing in healthcare, attending physicians may use 3D models as diagnostic aids and for treatment planning. Careful examination of a 3D model may yield clinical insight not as easier achieved with conventional imaging methods. Surgical specialists are particularly textiles individuals who are adapted as diagnosing and planning treatment based on hands or on information. A 3D model supplements the physical exam, allowing the physicals to multiple internal anatomy, evaluating pathway in the method not achievable with computer-based imaging. Model can also be used for pre-planning surgical technologies. Applications. So this is the applications of 3D print, 3D modeling. So first one, patient specific surgical models, and second one, new medical devices and instruments. The third one, bioprinting tissues, engineering, 3D printing, organs and behinds. So next coming to the applications. So I have taken 5 applications. First one, use it for personalized pre-surgical or treatment and for pre-operative planning. So coming to second one, testing different devices in specific pathway and improving medical education and patient education. And last one, improving the forensics particles. So this is a conclusion. Many types of 3D printers are commercially available. As this technology rapidly evolves, prices for these machines continues to decreases. Physicians and instructions in adding 3D models to their patients' care or teaching programs can do so with limited initial investment. The expand range of printing materials allow for virtual unlimited applications in this healthcare field. As teaching or diagnostic aids, 3D model offers a new and unique approaches to traditional medicines, supplementing and enhancing existing modelists. E has an of generative durable medicines, goods highly customized to individual patient need leads the opportunity to improve patient care and even provide care to patients previously undeserved. While currently the construction of 3D model is not billable to Medicare or Medicaid, a standing insurance companies as the technology is adapted more frequently into standard practice, this will be likely changes. So last one, references. So basically I have taken this many of references to complete my technical seminar. So this is a references which I took for my paper. So thank you everyone for watching my video completely. Please like, share and subscribe.